The National Electrical Code, or NEC, does not prohibit installing a breaker with a lower amp rating than the nameplate rating for dedicated feeds to highly featurable equipment, provided that the connector and flexible cord are rated for the nameplate rating. NEC Section 430.52b specifies that nameplates must be provided for all computers and shall contain information such as the ampere rating of the branch circuit to overcurrent protection. This section necessitates that a nameplate rating be used to determine the ampacity of the branch circuit over current protection. However, NEC Section 430.52 clarifies that the branch circuit over current protection should not exceed the ampacity of the branch circuit conductors. Therefore, a breaker with an amp rating less than the nameplate rating can be used if the ampacity of the branch circuit conductors is not exceeded. In a situation where the connector and flexible cord are rated for the nameplate rating, it implies that the ampacity of the branch circuit conductors is at least equal to the nameplate rating. Therefore, you can install a breaker with a lower amp rating than the nameplate rating without violating the NEC. This approach hinges on several key electrical engineering principles. Firstly, the nameplate rating of equipment, especially highly featurable equipment like large computers, often represents the maximum possible configuration and power draw. The actual power consumption in a typical or reduced configuration might be significantly lower. Secondly, the NEC prioritizes the protection of the branch circuit conductors. The overcurrent protection device, such as a circuit breaker, is primarily intended to protect the conductors from overheating and potential fire hazards due to overloads or short circuits. Thirdly, the ampacity of a conductor is its current carrying capacity, determined by factors such as its size, insulation type, and installation conditions. The NEC provides tables, such as those found in Article 310.15 and its related tables, to determine the allowable ampacities of conductors under various conditions. When selecting a circuit breaker for a dedicated equipment feed, you must consider firstly the nameplate rating of the equipment, secondly the ampacity of the branch circuit conductors, and thirdly the ratings of the connector and flexible cord. The connector and flexible cord must be rated to handle the full nameplate current of the equipment. The branch circuit conductors must have an ampacity sufficient to carry the expected load current, but not less than 125% of the continuous load, as per NEC Section 210.19a on for branch circuits and 215.2a on for feeders. The circuit breaker must be sized to protect the conductors, as per NEC Section 240.4, but can be smaller than the equipment nameplate rating if the actual load is less and the conductors are adequately protected. To determine the appropriate breaker size, start by firstly calculating the actual load current of the equipment in its typical configuration. This can be done by measuring the current draw with an ammeter or by consulting the equipment manufacturer's specifications. Secondly, select branch circuit conductors with an ampacity that is at least 125% of the continuous load plus the non-continuous load. Thirdly, choose a circuit breaker with a rating that is no larger than the ampacity of the conductors and no larger than the overcurrent protection specified in the equipment nameplate, if present. If the equipment nameplate does not specify overcurrent protection, the breaker can be sized according to NEC Section 430.52, which allows for higher overcurrent protection ratings for motor circuits, but this is generally not applicable to computer equipment. Consider a practical example. Suppose a large computer has a nameplate rating of 20 amps at 208 volts. However, in its current configuration, it typically draws only 12 amps. The branch circuit conductors are 12 American wire gauge THHN copper conductors, which have an ampacity of 25 amps according to NEC Table 310.15b16, assuming they are installed in a raceway or cable. In this case, you could use a 20 amp circuit breaker to protect the conductors, even though the nameplate rating is 20 amps. The 20 amp breaker is sufficient to handle the actual load of 12 amps and protects the 12 American wire gauge conductors from overcurrent. It is important to note that NEC Section 110.3b requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. This means that if the equipment manufacturer specifies a minimum circuit breaker size, that requirement must be followed. However, if the manufacturer does not specify a minimum circuit breaker size, the breaker can be sized according to the NEC as described above. Also consider the impact of voltage drop. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. When sizing conductors, you must consider the voltage drop as well as the ampacity. Software programs and online calculators are available to help you calculate voltage drop. In addition to the NEC requirements, it is also important to follow any applicable local codes or regulations. Local codes may have more stringent requirements than the NEC. It is always a good idea to consult with a qualified electrical engineer or electrician to ensure that your electrical installation is safe and compliant with all applicable codes and regulations. Furthermore, consider the implications of future expansion. If the equipment is likely to be upgraded or reconfigured in the future, it may be prudent to install a larger breaker and conductors to accommodate the increased load. However, you must still ensure that the conductors are protected by an appropriately sized overcurrent protection device. Another important consideration is the type of load. Some loads, such as motors, require special overcurrent protection devices, such as time delay fuses or inverse time circuit breakers. These devices are designed to allow for the high inrush current that occurs when a motor starts, while still providing protection against overloads and short circuits. Computer equipment typically does not require special overcurrent protection devices, but it is important to check the manufacturer's specifications to be sure. In summary, you can install a breaker with a lower amp rating than the nameplate rating for a dedicated feed to highly featureable equipment, as long as the connector and flexible cord are rated for the nameplate rating, the branch circuit conductors are adequately protected, and you follow all applicable NEC requirements and local codes. Always consult with a qualified electrical engineer or electrician to ensure that your electrical installation is safe and compliant. Proper grounding and bonding are also critical for electrical safety. The NEC requires that all electrical equipment be properly grounded and bonded to provide a low impedance path for fault current to return to the source. This helps to prevent electric shock hazards and reduce the risk of fire. Grounding and bonding requirements are covered in Article 250 of the NEC. Surge protection is another important consideration, especially for sensitive electronic equipment such as computers. Surges can damage or destroy electronic equipment. Surge protective devices, or SPDs, are designed to protect equipment from surges by diverting the surge current to ground. SPD are covered in Article 280 of the NEC. Also ensure to consider the ambient temperature. The ampacity of conductors is affected by the ambient temperature. If the ambient temperature is higher than 30 degrees Celsius or 86 degrees Fahrenheit, the ampacity of the conductors must be derated, as per NEC Table 310.15b2. The derating factors are based on the insulation type of the conductors. Furthermore, consider the presence of harmonics. Harmonic currents can cause overheating of conductors and equipment. If the load is likely to produce significant harmonic currents, you may need to use oversized conductors or harmonic filters. Harmonic currents are discussed in Article 220 of the NEC. Another thing to consider is the available fault current. The available fault current is the amount of current that would flow in the event of a short circuit. The circuit breaker must have an interrupting rating that is sufficient to interrupt the available fault current. The interrupting rating is the maximum amount of current that the breaker can safely interrupt. The available fault current can be calculated using engineering software or by consulting with the utility company. Another consideration is the coordination of overcurrent protection devices. Coordination means that the overcurrent protection devices are sized and selected so that the device closest to the fault will trip first, minimizing the impact of the fault on the rest of the electrical system. Coordination is important for maintaining the reliability of the electrical system. In the context of data centers and other facilities with highly featureable equipment, power quality is of paramount importance. Voltage sags, swells, and transients can disrupt equipment operation and damage sensitive electronics. Power conditioning equipment, such as voltage regulators and uninterruptible power supplies, or UPSs, can be used to improve power quality. UPS systems provide backup power in the event of a power outage, allowing equipment to continue operating without interruption. They also provide voltage regulation and surge suppression. Power quality is a complex topic, and it is important to consult with a power quality expert to determine the best solutions for your specific needs. Lastly, regular maintenance and testing of electrical equipment are essential for ensuring its safe and reliable operation. Circuit breakers should be inspected and tested regularly to ensure that they are functioning properly. Conductors should be inspected for signs of damage or deterioration. Grounding and bonding connections should be checked to ensure that they are tight and corrosion-free. Maintenance and testing should be performed by qualified personnel. Always remember that electrical work can be dangerous. It is important to follow all safety precautions and to consult with a qualified electrical engineer or electrician if you have any questions or concerns. The NEC is a complex document and it is constantly being updated. It is important to stay up to date on the latest changes to the NEC. Continuing education courses and seminars are available to help you stay informed. And always prioritize safety when working with electricity.